announce it.
What's up, though?
I do. Like you still do it.
Y'all ready?
You should.
No, it's not.
No, it's not.
Huh. So what we're doing today is simplifying rational expressions. So rational expressions are in fractions, yeah, like all these are examples. Okay, so when we simplify a rational expression, it's in its simplest form. Simplest form. When its numerator and its denominator are polynomials that have no common divisors. What does that mean? It means there's nothing left to cancel, divide, either one of those work. For example, these are in simplest form. A lot of people will try to cancel these x's. You cannot do that because this minus 1. Alright, if it was multiplication down there, then you could cancel it. But x minus 1 is a factor, a whole factor, so you can't cancel it. Alright, so these, nothing left to cancel, so they are in simplest form. Alright, it's beautiful, I know. Now, these over here can be simplified. Like in the first one, what can we cancel? An x with one of the ones on bottom, so we end up with 1 over x. Alright, the next one, it's a fraction within a fraction. We don't like that. So we'll rewrite it as 1 over x times 1 over x plus 1. So then we can just put those denominators together. And we could keep simplifying it, but for what you're doing on your homework today, you can leave things like this. As long as everything has been canceled and there's no fractions within fractions, we're doing pretty good. Alright, the next one, what can we cancel? X minus 3, so we're left with 2 over 3. Any questions? So basically when we simplify rational expressions, we are going to divide out common factors, which many times means that we have to factor. Yay! So like on this example, we need to factor. So what can we factor the numerator into? X and x.
X plus 5.
So we need two factors that, or two numbers that multiply to get 25, add to get 10. Plus 5 and plus 5. That is correct. Alright, what about on bottom? They have to multiply to get 20, add to get 9, plus 5 and plus 4. Alright, they're factored. Now what can we cancel? The x plus 5's there, so we're left with x plus 5 and x plus 4. Now that's not your whole answer, because we have to state any restrictions on the variable. What that means is points of discontinuity. So how do we find points of discontinuity?
Set the numerator equals 0.
Denominator equal to 0. Remember, because that's where the problems happen. Calculator catches on fire. No, calculator blows up, paper catches on fire. Denominator. So we need to figure out what numbers make the denominator equal 0. Now, which denominator are we talking about? We are talking about the one from the original equation. Okay, not just our answer. So, our original denominator, we factored it, so we'll use that. So, let me write out here what I'm doing. I'm finding the points of discontinuity. So, I'm going to set x, plus, having a lot of trouble today, 5 times x plus 4 equal to 0. Thank you. All right, and then how do we solve that?
X plus 5 equals 0, x plus 4 equals 0.
Yes, very good. So x plus 5 equals 0, x plus 4 equals 0. So what do we get for x? And
Negative 4.
negative 4. So the way we write this is we're going to take it up here to our answer. We're going to say we have x plus 5 over x plus 4, comma, x cannot equal negative 5 and negative 4. And that is your answer. So on all your homework problems, you have to state the restrictions. So half your answer is the simplified rational function. Half of it is those restrictions. So make sure you get that. Okay? All right, we ready to go on? Of course there's a back. All right, but we're not there yet. So now we get to simplify this one, and we'll still state the restrictions. That numerator, though, are we going to be able to factor it like we've been factoring? No, because of what?
The coefficient.
The coefficient, very good. That 2 in front. So, I'm going to bring that numerator over here and we're going to deal with it. When we have a value that is not 1, what do we have to do? Anybody remember?
Multiply A and C.
Multiply A and C, very good. So this is A, this is B, and this is C. We need what A times C equals, which is negative 4. We need factors of that add to get B, which is negative 3. So what multiplies to get negative 4 adds to get negative 3? Negative 4 and positive 1. Very good. Okay, so now we take that, we're going to put it over here. So I'm going to write, bring down my engine, bring down my caboose. Y'all remember that? Oh, never mind then. All right, and then we're going to split our b term into 2. We're going to use the negative 4x and the plus 1x. Now we throw in our dotted line. In front of the dotted line, what's common between the two? A 2x. So if we take 2x out of each of those, we're left with x. What's negative 4 divided by 2? Negative 2. All right. Now, in the back, behind the dotted line, there's nothing significant that is common, but we have to bring out something. So what should we bring out? A 1. So we're going to bring out plus 1, and that just still leaves us with what we had, x minus 2. All right, so what are our factors? X minus 2 and what's left?
2x minus 1.
2x plus 1. All right, whew. All that just to factor the top. All right, so this equals, on top we have x minus 2 times 2x plus 1 over, what do we have on bottom when we factor?
Negative 3, negative 2.
X minus 3 and x minus 2. All right, very good. Now, what can we cancel? The x minus 2's. So we get, yes, 2x plus 1 over x minus 3. All right, we're doing pretty good, but we still need our points of discontinuity. Those are restrictions on our variable. So what do we set equal to 0? denominator, and let's do the factored form, because we would have to do that anyways. So x minus 3 equals 0, x minus 2 equals 0. So what are our restrictions?
X cannot equal 5 and 2, and x equals positive 3.
Yeah, so x can't equal 3 and 2. Actually, before you flip over to the back, I want to do one more short example, just because I think you'll have one like this on your homework, and I want you to be able to do it. Okay, so write down negative 27 x cubed times y over 9x to the 4th y. All right, let's see if we can simplify this. What's negative 27 divided by 9?
3. Negative 3.
Yes, negative 3. All right, so we took care of those. Now, what about x cubed over x to the 4th? What does that leave us with? X. Let's leave it on the bottom. So x on the bottom, and then what happens to our y's? They just cancel and go away. So there's our simplified form. Now, that seems pretty easy, but let's look at the points of discontinuity. So we have to set our original denominator equal to 0. Any idea where we go from here?
Yep.
Yeah? Okay, so remember what we did was we set each factor equal to 0. Well, we actually have factors down here, all right? So this is a factor, and that's a factor. So we'll say 9x to the 4th equals 0, and y equals 0. Y equals 0, well, that's simplified. But the 9x to the 4th we need to simplify. So let's divide by 9. What's 0 divided by 9?
0.
0. Then we have x to the 4th, so how do we get rid of the 4th? Take the 4th root. What's the 4th root of 0? 0. So x equals 0. So what are our restrictions?
0.
Okay.
X can equal 0 and y can equal 0. You would need both of them. All right. Okay, this next problem for our regular classes, we are actually going to skip. All right.